Okay, just a second. Sorry about that. All right, we're back to normal. Okay, we have our stock right here, and it just drills through it pretty quick. I'm going to demonstrate that just a couple of minutes with the actual tool. And so these holes can be used for anything. Drill bits come in varying sizes, so obviously that would vary the size of the hole that it would create. This stock actually has some battle scars from where it was previously drilled. You can see these holes right here, they're like maybe 1/3 of an inch. And then there are holes of different sizes because they were drilled by a different size drill bit, so closer to 1/4 of an inch in diameter. And holes of different sizes serve different purposes, basically. So if you have a bolt that needs to go through a piece of this aluminum tubing, you're going to get that diameter of that bolt, which is, in our case, most of the time, it's 1/4 inch. You're going to get a 1/4 inch drill bit, which is coincidentally the one I brought with me, and you're going to drill through at whatever location is specified by the CAD drawing. So for example, in the CAD drawing, there's like the length of stock right here, and there needs to be a hole that's like 1/2 inch down and 1.5 inches down or up from this corner of the stock. What you do is you mark the stock, which I will show you how to do in a later lesson, and you'll use the drill press to drill a hole right in that intersection where those values are. And then it'll also specify what sort of diameter hole it needs to be in. And also something that we've used the drill press for in the past, we don't do that, which we don't do very often anymore, is that you can lower the mass of a part, such as this aluminum stock, by creating large holes just pretty much anywhere, because there are certain parts which, for example, in the robot that we built in 2018, there were certain lengths of aluminum stock which did not need to be particularly structural, but the robot was pretty heavy, so we needed to lower the mass of the robot. So what we did was we just got a really big drill bit, and we just drilled a bunch of holes into the aluminum tubing to make it much, much lighter. And so that worked. It wasn't very pretty, which is why we don't do it anymore, but it did the job. What we would do now is we would probably get the CNC and create some sort of pattern to cut into the aluminum tubing, but it doesn't look ugly. But that's one function that we've used the drill press for in the past. And also, we have these really cool gadgets. They kind of look like a drill bit, but not really. These are called drill taps. And I'm not sure if you can see, but they have these little ridges. And what these do is that when it drills into the stock, it cuts these threads that are used to thread a bolt through. And I'll show you guys how to tap when we get back into the lab, because it's not really something that I can show through video. It's something that's basically that can pretty much exclusively be learned by hand. So that's why I'm postponing that for now. But what the drill press can do is that since the drill chuck is always vertical, it's very good at aligning that drill tap so that it's always perfectly vertical into whatever you're tapping, which is very useful. So we have 2 drill presses, as I said before. The small one is right next to me, and the other one is in the lab being packed up. So the drill press at our lab, it has this light or a laser. It just makes an X, and the intersection of that is really close to where the drill actually goes once we lower it. Yeah, I know, the lab is gone. I'm very sad. And it also, next to the mechanism which lowers and heightens the drill chuck, there's an indicator which lets you know how far down the drill chuck has gotten. And that helps you in case you don't want to drill all the way through a part. And also, in both cases, for both of our drill presses, it has a base for which you can set down or clamp down a part so that the part does not move and just has a place to stay while it's being drilled through. All right, now we go on to the really important stuff, the safety. What's the number one rule around here? Safety glasses, okay? I'm gonna put mine on right now, all right? Obviously, this tool isn't like, yeah, it's just, you're never going to need anything more than safety glasses when you're using the drill press. And I see Ashton has his, so he's setting a good example as well. And something else that's important is that when you're setting a part on the table and you're drilling through it, keep in mind the hand rule, the hand placement rule. For example, if I have the drill and let's say I set this on the table and I have my drill right here, I shouldn't keep my hand gripping the part when the drill is right here. You know what can happen? It's very easy for something to slip, and my hand is like, oh no, and you know, anything could happen, and for whatever reason, my hand comes in contact with the drill, and suddenly I drill through my hand. That's no good. We don't want that. That's very dangerous. So if we keep your hand a safe distance away from the drill bit, at least one hand length away, so like that, you should be safe. And to prevent that from happening, what you do is you get a vise, which I don't have here, but I do have a clamp. So what this clamp does, for those of you who haven't seen this before, it's just this cool little tool. It has this, it's the thread right here. You can tighten it and loosen it up. What it does is it can pinch things in order to stop them from moving. For example, if I just loosen this up real quick, I can demonstrate. There, that's connected to the bar. So what you do is you can, for example, clamp the bar to some sort of base, such as the one we have on the drill press, which is what you're going to do. And after the clamp has been tightened down, what will happen is that this part doesn't want to move around anymore when it's being drilled, which is how you can stay safe and keep the stock stationary so you don't have to worry about it moving when it's being drilled. And in some rare cases, it will be necessary to apply coolant, which is again this blue liquid that we keep in these spray bottles. But you're only really going to need to do that if you're drilling through like a solid block of metal. For aluminum tubing, you're going to be able to drill through it pretty quickly, so you won't need any coolant to keep the part from getting too hot. In fact, the drill press doesn't really get hot at all. It doesn't get the metal hot at all. It just keeps it like warm. But in cases where you're drilling through a solid block, it's a really good idea to just spray the coolant onto the part a couple of times right where it's being drilled so that it can stay cool and you won't burn yourself. All right, so I want to remind you all, there were probably a couple of people who came in a little bit later, that I do have this video prepared on the Gearhead YouTube channel. In fact, I could probably just put the link in there again as a reminder. And what you can do is that in your free time, you can feel free to watch this. I'm not going to watch it right now because I'm going to demonstrate everything that I want you to know shortly. But basically, if you want a refresher anytime, I just prepared that video yesterday. It has all of the basics that you need. So especially, I'm going to want to have you guys rewatch or just watch those videos before we go into the lab, which is probably going to be sometime next semester. So I just want to remind you all that these videos are here. I also have one for the hand drill, which I'm going to present right now. All right, so the hand drill, the multi-tool for building game pieces. This, the hand drill that we have, it can drill holes the exact same way that the drill press can. It has a drill chuck so that you can secure a drill bit right in there really quickly. And it basically just functions the same way that the drill press does, except that obviously this is mobile. I can move it around. I have it in my hand. And you can't really do that with the drill press. So what other use this has is that there are bits like this. You see this one, for example, with star shaped. Once it's secured into here, this bit can be used to lock with some sort of screw. And the screw can be drilled into wood. And it's as simple as that. You have a screw which can join two pieces of wood together, and which is obviously, like, I would say 80% of what goes on building the game pieces. And also for the taps, I've mentioned the taps earlier. This is going to be what you use to actually tap things in, because you can adjust the speed of this. See, I can go slowly, and by pressing the trigger more, I can go more quickly. You're going to need to go quite slow when you tap, which again, we will learn when we get back to the lab. But it's just important that you use this instead of the drill press, because the drill press goes way too fast to actually tap without breaking it. And so our hand drills in particular, again, we do all of our tapping with our drills, and our drills also have these variable speeds and torques, which you can use. And what these do is it makes it so that you can adjust the speed or the torque depending on what your need is. So basically, I have this switch over here. This adjusts the speed of the drill. I have it at 3 right now because I was drilling into something earlier. Basically, 1 is the lowest and 2 is in the middle. I think at the drills, for the drills at our lab, we only have speeds 1 and 2. It's fine. All you need to remember is that the lower speeds are better for applying screws and tapping, because speed is not what's important there. But you do want to go faster for drilling through aluminum. If you ever get into a situation where you need to drill metal with a hand drill, then you probably want to go slower again. And we also have this, which is, you see there are a bunch of numbers over here. That basically tells you how much torque you're letting the drill have. And so, for example, number 1, that if you have the drill set to 1, that means that it's very easy for the torque to sort of override, and it won't, it'll basically just stop once it hits a certain amount of resistance while screwing something in, for example. So you're going to use, for example, when you're screwing something into a piece of plywood, you're not going to need to use the highest torque possible. What you're going to want to use is probably something like, well, the levels are different for every drill, but this one goes from 1 to 11. You're probably going to use like 5 or 6 for plywood. And so what that will do is it'll allow you to screw the screw in all the way, but it'll make it so that the drill stops before the screw like sinks all the way down into the plywood to the point where the head of the screw gets buried into the wood, which is something that you don't really want, because if you want to take the wooden assembly apart, it would be annoying if you were to bury all the screws in there, because, you know, yeah, it just gets, it's just really hard to get out that way. And you go higher and higher until the point where, I'm not sure if you can see this, there's actually a little drill symbol. That's the highest torque that the drill goes to, and that is for actually drilling, like using a drill bit to drill holes in things. And the reason why it's important to have the highest possible torque for that is because you don't want your drill to just suddenly stop when you're drilling through something. So what you need to know is that high speed, high torque is for drilling through aluminum with a hand drill, and low speed, low torque, or varying amounts of torque, is better for screwing things in. And low speed, low torque is for tapping things in. And so now we need to go back to the safety. Again, I want to remind you, you'll be very annoyed at me saying this all the time, but you need to have these safety glasses always and forever in the fabrication area of the lab. All right, so we've always had a little bit of a problem with, like, someone is using the hand drill, like they're maybe drilling something in or screwing something in or whatever, and they take this and they carry it back to an area where, let's say, people are catting or something, or people are putting something together, and none of them have safety glasses on. and they start using the hand drill right next to them. That's not a good idea, especially if you're drilling, because especially if there are people who aren't prepared for a power tool right next to them, because that puts them like, if they aren't prepared for the tool to be right next to them, that's just like, it marginally increases the risk of them being injured. You're not going to get seriously hurt with a hand drill, but obviously it's still highly preferable that you're not going to be injured at all by any means from any tool. So what you need to do is that if you have to take the hand drill and use it somewhere where there are other people, you should kindly ask them to put on safety glasses before you use it around them, or, and most of the time they will, and yeah, just ask them, and everyone should be a-okay. And again, this is just a reminder, sometimes if you set the speed too high or the torque too high when you're doing something like tapping, it becomes very easy to break taps. And in some cases, it can damage the motor of the drill. Like, for example, sometimes the motor can start to overheat, which obviously isn't good for the drill. So you just want to adjust the torque and the speed of the hand drill according to what task you're doing, and you should prolong the life of that tool greatly, which would be obviously preferable for everyone here. And again, I have a summary video about how to use the hand drill on YouTube. So, and that's that. And so that concludes this lecture portion of the lesson. And what I'm going to do now is we are going to learn how to actually use these. So I'm going to show you step by step, specifically how to use each function of these two tools, which should be very fun. So what I'm going to do is I'm going to take this, this, and this, and move over here. All right, y'all see my other camera? I'm going to turn off this camera right now. And I'm going to be here for the rest of the lesson. All right, hello everyone. Oh, and by the way, John and Ashton, if there's like a question going on in the chat, I can't see the chat on my phone, so you guys should just tell me if there's something that someone wants.
Okay.
All right, thank you. All right. So here is our drill press. What you're going to need when you're using a drill press is we have an assortment of drill bits of varying sizes over here. We obviously have the tool itself. We have a clamp to secure the parts. We have our stock. We have the bit, which does the actual cutting. And we have the chuck key. Now what this does is, I'm gonna show you close up. So you see this? This is the chuck key. This is the mechanism that holds the drill bit in place. And so what happens is I can use this key to adjust whether or not these teeth down here are tight enough to accept a drill bit. So obviously, lefty-loosey, righty-tighty, and you can usually hand loosen or hand tighten it. It's not very fast when I do it with one hand, obviously. But this is just how you loosen and tighten it to accept varying sizes of drill bit. Okay, tighten this now. And boom, there we go. I just hand tightened, or I just changed the size of the bit that goes in there. So actually, no, I shouldn't do this. I should get you back close. So I showed you guys, well, I described some mechanisms to you all briefly, and I want to show you them in person. This is the mechanism that lets you lower and increase the height of the drill chuck. And this is the table with which you rest the parts on when the parts are being drilled. And you can adjust the height of this using this mechanism over here. Again, lefty-loosey, righty-tighty. And yep, you can adjust the height like so. This table's kind of wobbly, so I'm not going to go crazy with that. And you just tighten it up again, and you can't move it anymore, which is awesome. So now you know it's quite a simple tool. There's not really much to it. And now it's time for us to have a little bit of a design session. All right. So let's say, all right, here's a blank piece. So imagine that this is just an unaltered piece of aluminum stock, and Kyle or Ben or Sid or Caleb, or Caleb Nomi, or anyone else really, they say to you, hey, I want you to build a new part. And you say, okay, what are the specs? And so they say, I want a piece of aluminum tubing that has a hole right here. And then they're going to obviously specify through CAD drawings what, like where exactly the part or the hole is, which, you know, we're going to pretend that they gave us an actual number. And what are you going to do now? Well, obviously you're going to drill. You're going to drill wherever the CAD drawing tells you to drill a hole. And you observe the CAD drawing and you say, oh, it's this distance away from this edge and this distance away from this edge. This right here is exactly where I want to drill. And you're going to mark that exact location, and then you're going to observe what diameter of hole is needed. Let's just say, for example, the hole is 1/4 inch because we want to stick a bolt through it. That's a 1/4 inch diameter. So what you're going to do is, like I just did, you're going to put a 1/4 inch drill bit right into the drill press. So what you're going to do next is you're going to align the part where you want to drill. So you're going to say, oh, that's perfect. This is exactly where I want to drill right here. So what are you going to do next? You can't just start drilling right here. No, that's too dangerous. Look at how close my hand is to the drill bit. So what we're going to do instead is you're going to get the clamp. Oh, wrong way. And, oh, sorry, this might take just a little bit of time. There we go. And there, if we look closely, you can see that this clamp is preventing this part right here from moving. And so then we have the drill bit exactly where we want it to go on the part. And we're ready to start drilling for real this time. So I want to teach you guys something really quick. It's a very common technique that preserves the life of the drill bit, and it keeps the part from getting too hot. And what this is called is peck drilling. So this peck drilling isn't necessary for most aluminum tubing. And so you don't need to do it when you're drilling through aluminum tubing, basically. But if you have like a solid block of aluminum, then this is very helpful to learn. So what peck drilling is you basically start drilling just a little bit, and then you stop, and then you go all the way back up, and then drill a little bit more, and a little bit more, and a little bit more, going back up each time, which lets out the drill shavings, which preserves the life of the drill bit, because getting the drill shavings out of the way is good for the drill bit. And it also makes it so that you're not providing a constant source of friction for the part. And it basically just gives the part a tiny little break to cool down, to cool off. And it makes it so that after you're done drilling all the way through, the part isn't super hot. So this is what it looks like. I'm going to take you guys down again for like a millionth time. Sorry about that. Here's the on button. So now the drill is running. This is what you do. See, I just drilled a little bit, and a little bit more, and then a little bit more. And so You saw that hole get deeper and deeper as time went on. And you also saw those little things spinning around the drill bit. That was the drill shavings that were escaping. And this is a great time. This is what a drill shaving looks like. We have them all over the lab because we use the tools all the time, obviously. So I'm just going to finish drilling all the way through, and I'll show you guys what the finished thing looks like. All right, ta-da, we did it. There's our hole right there. Now, if that was really the only thing that we needed to do to this piece of aluminum tubing, we would, yeah, it is beautiful. We would take it over to whatever bin that we have for this mechanism. Let's say this part was for mechanism 2, which was a shooter that launched basketball. We would put that in whatever bin was labeled mechanism 2, basketball shooter. We would put it in there, and we would label the part, whatever part number it was, and then, bam, we would be done. Part completed. Great job. So that is basically the only thing that you will be doing for the drill press. And I want to say that there is just a couple of things. These drill bits right here are used for drilling through metal. And there are different types of drill bits that you can use for wood, because occasionally you will be drilling through wood on a drill press. They're called Forstner bits, and they usually get, most of them can get a lot bigger than normal drill bits. You can drill through wood with these if you need to, but what you need to know with those Forstner bits is that you just need to go a little bit more slowly with them, since they're a lot bigger and their area makes it so that it's harder on the drill press's motor. So going slower is a good idea when you're using a Forstner bit. And also, if you can see right here, this is an old drill press. So it has, people have made a lot of mistakes on this. You can see all these little holes, right? That is from people adjusting the bed, but forgetting to align the drill bit with the center hole right here. So people have just drilled all the way through the bed without realizing. You always need to make sure that the drill bit aligns with that center hole right there, or else that'll happen. It's not good for the drill bit, obviously not good for the drill press. It's not going to destroy the entire tool, but it's just nice not to have holes everywhere, because if it's nice and clean, it has no holes at all, then it's just slightly more useful. You can clamp things just a little bit better to it, and yeah, it's just less ugly in the long run.
Caleb, we can try to clamp a biggish piece of like MDF that's like, I don't know, like half an inch to 3/4 of an inch onto it. So then people can go kind of into it. And if it's on accident, then it's going to go into the wood itself rather than into the metal base.
Oh yeah, totally. So something that you can do is, like Ashton said, a lot of the time people are concerned about drilling all the way through a part and then drilling through the bed on which the part is on. So what you could do is you could just sandwich a piece of, wood, any type of wood, between the part that you're drilling. It's really common in woodworking. So like if you have a huge Forstner bit that you're drilling a big hole through on a piece of wood, you get another piece of scrap wood that you're going to throw away, and then drill all the way through your good part, and then drill just a little bit through the scrap wood. And then, yeah, that's a really simple solution. Thank you, Ashton. That's a great point. I actually use that quite a bit when making game pieces. So yeah. I also want to tell you guys that since I don't have a vise here, I want to just explain this to you really quick. We had these little portable vices. They were like rectangular, and what they had was they had these two jaws, and it worked kind of like this. But it was just they just they laid flat on the bed of the drill press, and obviously you could just tighten the jaws, make them closer or further apart, and like, just capture the part that you're trying to drill. And they weighed like maybe 4 pounds. So, and they were great for they did their job really well. But the thing is that if you had a tiny little part with the vise, if you had a vise gripping the tiny little part and the drill bit was like kind of dull and it caught on the part, there was a chance for that vise to like swing around with the drill bit, like while it was spinning. That happened like a couple of times before. No one got hurt, but that's just, nonetheless, it's still pretty dangerous to have that happen. So what you need to do is that when you have that vise holding the tiny part, you need to clamp the vise itself down to the bed with the clamp, obviously. The clamp is like the S2 lever. And so when you have the vise clamped down to the bed and the vise is clamping the part, there's no way anything is going to go anywhere. It's like rock solid. Nothing is going to escape at all. And yeah, that's all I wanted to show you guys for the drill press. So yeah, I think I'm going to move on to the hand drill now. Ashton or John, is there anything you guys want to add? Any?
You froze on my end. Oh, never mind. It's back.
Okay. I was saying if there's anything you guys want to add, any facts, any stories, any tidbits, anything that I forgot that you think we should talk about.
I really love the drill press. It is so epic. You can drill such straight holes.
Yes.
All right.
Man, when I try to use a hand drill, it's so wonky.
Okay. Okay. I hope you all have considered Ashton's love of the drill press, and hopefully that that bolsters your knowledge overall for this tool. All right. What I'm going to do now is I'm going to bring the hand drill over here. And we're going to repeat the same procedure, but with a hand drill. There's going to be some key differences here. So let's say we go through the same story. I need to drill a hole right around here with this piece of aluminum tubing. So how am I going to do that? Well, I'm not going to use the drill press at all, obviously, because we're not using the drill press. We're using the hand drill. So what we're going to do is we're going to lay the part on some sort of flat surface. And we're going to repeat what we did with the drill press. With a clamp, we're going to clamp the part down onto the table. There we go. Now it's nice and secure, and it won't move anywhere when we try to drill it. All right. So let's see. Oh, whatever. I'll just do this thing. So again, lefty loosey, when you're doing this on the drill chuck, you start it, and then it loosens up, and then bam, you can get it out of there. All right. So most drill chucks are different from these drill press chucks. So you guys have an idea of what those look like. These are a little bit different. They work pretty much the same way. You see, if you spin it to the right, these fingers right here are tightening and tightening and tightening so that you can accept smaller drill bits. So I'm going to loosen this up until I can fit this in, and then I'm going to tighten it up. And then I'm going to keep tightening it until I hear those clicks, like you're cracking your back or something. That's what it sounds like. So when you hear those clicks, that's how you know that the drill bit is nice and firmly in place. And yeah. So what I'm going to do is I'm going to use the same pec drilling technique. And yeah, I'm going to, since this is a big part, I'm going to put one hand like maybe a foot away from where I'm drilling, a foot or more. And what this is going to do is it's going to help further stabilize the part, because having just one clamp means that it can sort of rotate You can sort of rotate around where the clamp is. You see it's perfectly still, but it's just rotating around there. So if I have a hand right here, that means that I can just drill right here without any worries, which is what I'm going to do right now. And there we go, another hole. And well, I wasn't pipe drilling because I knew that it wouldn't take that long. But again, I want you to keep in mind how useful pipe drilling is for solid blocks of metal. And I also made sure that my drill torque setting was on the highest level, which is just a picture of a drill bit for some reason. And the speed setting was also at 3, which is the highest that this goes to. I'm not sure if you guys will be able to see it, but this is how fast it spins on 1. This is how fast it spins on 3. I don't know. I don't think you guys can see that very well, but whatever. So now you can use the same process to attach this screw bit right here. And let me just get a screw real quick so I can show you how to do that. So you see that these two match each other right here. Obviously you can tell because they interlock and they're stuck to each other now. So what you can do is you'll be able to screw into like a piece of wood. And let's see, I can just drill into here for right now. So I want to make sure you guys can see this. All right. You guys can't see it very well. No, that should be better. All right, so I just make sure that it's nice and aligned. And I almost forgot, I need to lower the speed setting down to here and also lower the torque setting so that I don't ruin anything. So here we go. There we go. Super easy. You can see, I'm gonna get you guys closer. The screw is really pretty far in there, but if you guys don't have a lot of experience with like construction related activities, screws are really useful for like joining two pieces of wood together. For example, if I had to connect two pieces of wood, I would just use a couple of screws and screw them in together that way. And so getting screws in is fine, but what if, for example, I made a mistake? I don't want that screw to be in there anymore. So what I want to do is I'm going to change the direction of the drill bit. You can see right here, it is, well, at least from my perspective, it's going clockwise, so righty-tighty, right? If I push this button right here, it's going to make it go the other way. It's going to go lefty-loosey. So what this means is that if, for example, this was a mistake, I would be able to get the screw out by going left. And there we go. It's back out again. Super easy. So as you can see, in terms of getting screws in and out with the hand drill, it's super easy and it's also super fun. If you like building things super quickly, like in the course of a day, that's where you would really want to specialize in making game pieces at the start of the build season. So yeah, that is all that I wanted to go over today. So I'm going to end this right here. I'm going to stop this video, and I'm going to return to my throne back at my main camera. Hello. So, in review, we learned about the drill press and the hand drill. This is like one of those cases where a tool is very versatile, so it's hard for me to like pinpoint like a specific example, which it's hard for me to pinpoint like one specific use for it, because I mean like just drilling holes in things isn't a very good definition for a tool, but that's kind of like what makes the tool so great. So yeah, what a lot of common applications for this is that you have mainly we drill holes for letting bolts through a piece of aluminum tubing or letting rivets through a piece of aluminum metal. I have a piece right here. As you can see, we have these holes right here. I don't think these were done with a drill press, but in the past, we used to drill these size holes all the time. And what these are is that they are the perfect size for aluminum rivets. Let me show you what those are. So these are aluminum rivets. What they do is there's a special tool that you use. It looks like a pair of pliers, and you squeeze it, and what it does is it pulls on this little metal stick right here, and it pulls this bulb looking thing through, and it warps the metal at the end of this rivet such that it makes it so that these two bits of metal are stuck together. So that's really useful. We have hundreds of rivets on our robot made out of aluminum, and the advantage of having a rivet be out of aluminum is that you can drill through the rivets and take them out really easily. And rivets are comparatively very light with steel bolts. Like, if you have a choice between attaching two pieces of metal with a rivet or a bolt, a rivet's like a tenth of the mass of a steel bolt of like a similar length. So that's just a really common application that you see. I remember spending hours my freshman year drilling holes for bolts and rivets, and to a certain extent, also drilling holes for bearings. You see these larger holes right here are meant for bearings. What bearings are, I don't really have them here right now, but they're just, they let you spin like a piece of round stock. Like what it is you have a bearing in this hole, right? And the bearing has an inner hole within it. It's shaped like a donut. And so with this inner hole, it makes it so that anything within that inner hole can spin with almost no friction, which is good for gearboxes. We have several bearings in each gearbox for the drivetrain that we use. And I would suggest looking into just really getting into what rivets do and what bearings do, because those are like two really big things in fabrication that we have to build around. You know, it's like, I don't know, it's just, they're really integral to building a robot, and they're also really interesting. So that's sort of my extra bit of the day. And Ashton, oh my gosh, it was like 5 minutes ago, but I'm not gonna tear down my garage. It's okay, Ashton. Yeah. So next week, this is what we'll be doing. Basically, for the next 8 or 10 weeks, I think it's just gonna be a different tool every time. This time it was a double because it was two relatively simple tools. Yes, John, this is a pauser's moment. Yeah. Thank you, Caleb. I'd like to thank everyone. This lesson will be recorded onto the Gearheads YouTube channel. Again, I know I'm being annoying, but check out the channel, subscribe to it. There's going to be a lot of lessons from every sub team that you could ever want. There's going to be a bunch of information on there. And there's also a lot of season recaps that you can watch and gain an understanding of what our club is about. Because, since we can't be in person, you can at least watch, like what we did 2 years ago at CVR. And yeah, CVR. That was the one where we did really good. Yes. You don't need to wear safety glasses when you watch the demos, but I'm not saying it's going to hurt either. So basically, the main takeaways from this is that you know how to use the drill press now. You know how to use the hand drill now. After you get some practice in with both of these tools, you'll be able to get really good at using them. And these also have some really good real-life applications because these aren't tools that are used exclusively in robotics. They're used everywhere. So yeah, hopefully you gained a good bit of knowledge. And I would like to thank you all. And I will see you next Tuesday at 4 p.m. And I forgot what we're doing next week, but I think it's just going to be one tool. And yeah, it'll be something completely different. So I would like to thank you all. And I'm going to say goodbye.
Have a good day.
Take care.
Yeah. All right.
Oh, it's just us.
Yeah. Farewell.
Farewell. Have a good day.
Have a good day.